Thank you. It's not over yet, so I'm just starting. So the deal is, this is an in-person conference, so we should enjoy it. So what I expect from you, at least one question. And I brought some hats, so you get the first 3 hard questions, get on a hat. And but don't tell me make the font larger. This doesn't count. Okay. I was invited to JDD, I think last year or 2 years ago. And what I did back then, I say JDD, I know it somewhere because it's always pro Java, and and then I went to my outbox or mailbox and found emails. I think it was the guy with the megaphone from 2007 or 8, and then 2012. And what I found, my own talk, and the name of the talk was Java is 6 and the future is now. It's like, okay, interesting. So after 10 years. Was I right? Was I wrong? What about the code? And I found the code. I have the original code from 10 years ago. And then the origin plan, what I did the online version of JDD. In the first 10 minutes, I hacked the code that is working. So it works now. What I did back then, 2 years ago, I use Whitefly with Java 15. So this is boring. And what I would like to do today is not just to show that the code is running, because no one learns anything. It will run. But I would like to explain you what's changed and how we can use Java effectively right now in and outside clouds. I don't care where, but if you go to clouds, it's something different, and without clouds, it's also different. Who uses clouds? Deploys to clouds? Almost everyone. That's interesting. And who on-premise? So I do both, but clouds are coming, and I will explain you why they are coming. It's interesting. So my name is Adam Bean, and this didn't change. What I did, the first time ever, yesterday, I listened to my own talk. I hate this. And 10 years ago, and how I introduce myself, that no one believes that my name is Bean, because there are Java Beans and enterprise Java Beans. So this changed because no one is excited about Java Beans anymore. So, but the Mr. Bean, what also changed is, you know the Mr. Bean? Yeah. I didn't like the Mr. Bean at all, but 2 years ago I watched his first movies, and they're actually fun. Now I like the Mr. Bean, so now I know. This changed in the 10 years. And I have a podcast just for fun. There are some topics, if you're interested, with various people from community about this particular topic, Java, serverless Java in the clouds. Is it worth or is it not worth? And so funny story is, I think 1.5 years ago, I delivered a workshop, online workshop for a company, which is actually, I found them also here in the area. And they say, okay, Java in the cloud is crap. So, and we wrote, a Hello World application, and it took 15 minutes to start. So, okay, can I look at the code? And they showed me the code. I think they had already 5 logging frameworks integrated to the one-liner. And until everything was loaded, it took, of course, 10 seconds. So what I plan to do is, if the internet will work, is to show you how it usually feels with Java. Okay, so this is also somehow relevant. So what this is, the first Monday of the month, I'm answering questions. You can just write your question to GitHub gist, and I will live answer the questions. But what's cool is I have already over 100 episodes, 103 episodes. So this show is 8 years old. And what I'm doing, I got the idea because of the conference. I'm looking back 100 shows back, which questions were actually interesting back then and what changed. And what's interesting is, and of course all viewers do the same, it didn't change a lot. It's the same questions, this is like, we are talking about the same stuff for 10 years. So it's a great time to be a speaker. You don't even have to rewrite the slides. So there is the online workshops, if you like, in December, just online. And this was me on YouTube, so you can still watch the talk. If you search for Java, future is now, but it's not even distributed yet. You see nothing changed. I look exactly the same. For energy reason, my logo doesn't glow anymore, so I had to set it off. But back then we had more energy, but right now we are more energy efficient, so nothing. There is no lights on my notebook, but I wanted to find the shirt, but I don't have it anymore, I think. But it's similar, so you see I look exactly the same, nothing changed. So in 2012, I listened to my own talk, and what I found out, I was really angry during the talk. I had in mind a project with crazy architects. They forced the entire development team to write 20 layers, And this is what I talk about. This changed. So back then we had Java 6 and Java 6, and I liked that a lot, and I have to admit my code right now looks almost identical to back then. So it is a little bit leaner, but almost no different. So we have now Jakarta E10, but no one cares about Jakarta E anymore, and also not about microprofile. We use whatever you use, and it happens to be something from Jakarta E and something from microprofile. I tell you why. So what back then, that's still 2012, we had wars. So we have also a war, a different one, but we had the nicer wars back then instead of years, and now we get jars. You will see in a second. And back then already, I was against shared deployments. Like, look, it doesn't make any sense. We have an application server, the overhead is minimal, and you are now pushing 10 applications inside the application server, and this is higher risk than just, using microservice like this. So I was against that, but it was very popular back then, especially in Germany. I don't know about Poland. Everyone wanted to have shared deployments. And by the way, I'm glad that I'm not alone here. So at the beginning, I was afraid. If I'm alone, it's really hard to get questions from empty chair, right? So then what's cool? So I looked it up yesterday night, actually. Docker was released 2013. So the talk was before Docker, and Docker changed a lot. What's interesting right now, in my current projects, I don't use Docker anymore. I mean, not even containers, so it's interesting. I'll show you also why. I mean, in some projects, of course, but in my current project, in larger projects, no Docker. And server-side rendering, JSF, were very popular. This year, we migrated a JSF application to the cloud because they couldn't migrate it to anywhere else. So I wouldn't use JSF in the cloud anymore. Why not? Because there's always a little bit problem. The only problem with JSF is the load balancer. So if you have multiple instances, JSF is stateful. So you have to set up the load balancer, and this is too complex for me. I mean, also, okay. So we see the first difference between back then and now. I would say the big difference to me, we also have to care about infrastructure. And the biggest difference to back then is the source code almost doesn't matter. I spend the majority of my time, fighting security groups and IAM roles and credentials and, cognito and tokens and stuff like that, which is really painful. It's not fun. So if I hear DevOps is for me like, Visual Basic programming, something really, crazy stuff. You work the entire day, and at the end of the day, you see a button on the screen. So exactly how Java started, with the Xdocklets and huge generation. So who knows Xdocklet actually? Xdocklet? Cool. So now we have Helm, right? With Kubernetes is very similar technology from Helm, like back then. So hot deployments was a big thing. I was always asking, JRebel, you remember Java Rebel, JRebel? There were tools which online, this is interesting. This is exactly opposite to now. Back then, we wanted to have a servers which are always, current, and they were always updated, and right now it's gone. Also, what I really liked is this, strict separation between infrastructure and application logic. So I always told you, application server are the best thing ever because I deploy the application server, I buy support from Payara, which by the way you can still do, and then I package my application war and can deploy. Okay? This was the interesting part. Now we get it back. So this is also interesting. So this slide I created yesterday because I was like, what is it? This is actually a lot's going on. So back then we had larger machines. So all my deployments were at least 4 cores machine. Agreed? 2 4 cores or beefier machine, 1 application server. Last week I reviewed a Kubernetes project. They had a half a CPU for the microservice. If I have a half a CPU for a microservice, I can use system out println for logging. I can do whatever I like. There is no parallelism anyway. So I mean, the likelihood that 2 threads will meet in a method, forget it. So this is complete different world to back then. So it means in modern world, I have no problem to use system out println for logging because it doesn't matter. And back then, we were very, we thought hard about, not using singletons, synchronized locking, and now there's no locking because there's no parallelism. Okay? Also interesting finding. And clustering and caching was big, and now Java developers in my project still would like to have clustering and caching. So can we cache something? No, forget it, it's too hard. Why it is too hard in the cloud? You have to buy something, put in between. And of course, something like Hazelcast, for instance, only works inside the JVM. If you move the caching outside the JVM, you get deserialization. And then, the guy from before, the security expert will, inspect the serialization, find some bugs, and we are screwed, I had a chat with him. He's like security expert, so I have to be really cautious what he says, and don't show him any code. So this is my suggestion. So back then, clustering. I didn't use clustering at all. So even then, what I used, independent application server was a load balancer, and the load balancer was Nginx, not HR proxy. Never use Nginx actually for HR proxy always. Or companies had, the hardware load balancer, IP5? F5, F5 exactly. And also interesting, I watched the talk. I used only to telling you why JAX-B, Java architecture for XML binding, right? And the problem was the JSON was always different. It depended which application server you used. And now we have JSON-P and JSON-B, which is easier. So no kidding, I have no time to explain it. EJBs for simplicity, I still like them. Why not? Because if you remove EJBs, I have to add 2 more annotations. That's the reason. So what I did, there is another, Greg, what's his name? He does the large conference here, also in Krakow. How it's called, the conference in Krakow? By the way, if you have to ask questions, the DevOps, right? And no one dares here to talk about DevOps maybe. But he invited me to talk about serverless. And what I did, the talk is online, you can watch this. I explained AWS Lambda with EJBs. And the cool story is identical. If you know EJBs, pooling on everything, you can apply it one-to-one to AWS Lambda or Azure Function. It works exactly the same. The only difference I show you in a slide. Right? This is the same thinking, pooling, cold start. This is identical. Min pool, max pool, provision concurrency. It is actually one-to-one with different names, which is actually cool. And the entire session I talk about that. And there's no time to explain you, but I still like them. But they walk away. They are no more there. And what we use instead, CDI, in all projects actually. So with request, scoped, and transactional. So what we create a stereotype at boundary. It's exactly the same code. Works like EJB, it is not EJB. What we are missing more often than not is the ability to pooling. I give you an example. You know GraalVM. I had a chat also with the guy before me. And what GraalVM is able to do, it is complete Node.js compatible environment, GraalVM. And sometimes we would like to load JavaScript to Java. But the GraalVM loading takes time. So with EJBs we pulled the EJBs. Every EJB had an own GraalVM with JavaScript environment. Was pretty cool. So there's no way to do it with CDI, but because there is no notion of pooling. One example, which is lacking, and this is lacking everywhere actually. So single dependency API, this is what I liked, Java is 6 and go for it. Don't talk about, dependencies. This is gone more or less because what now happened is, what I also don't like it, how it looks like now in Quarkus, Helidon, and all our environments, I know I have to add all the dependencies. It's always the same set of 10 dependencies. It's really stupid, but it's like it is. I'm the only who is now against that. Everyone don't mind, but I don't like it. I'll show it in a second. And 2012, layers, I just deleted a lots of layers, and they were very popular back then. Especially now in Poland, but the Germans were crazy, on Switzerland, crazy about layers. The more layers, the better it was, right? It was like one table with 2 rows, 2 columns, and we had like 10 data transfer object and mappers and layers and whatever. Recently, I even found the dozer. You remember dozer? This is end of life. It's interesting. So it's no more maintained. So all the dozer projects right now have a real problem because if there is a security bug, they are screwed, right? And no problem because they are migrating to Lombok right now and hoping it is getting better, right? So this is so. We have application runtimes. There was one podcast at the beginning. I discussed 1 hour until I understood the difference between server and runtime. So servers support shared deployments, and runtime is one-to-one relation. That's the difference. What I use a lot right now is Quarkus everywhere, and it's getting more and more popular. Why? Interesting, because of startup time. The startup time of Quarkus is very low. What it means, you can save money. This is the first time in the history of Java where we go to management and say, look, if we do this, we save, there is a calculator, Azure calculator or AWS calculator, where I can prove that we will save money. Done. And the cool story is, we have time for that, but it is not necessary to use GraalVM to do that. It is sufficient just to use Java. So no class loaders, no reflection. Interesting. So Helidon and Quarkus and Micronaut, they're not using reflection at all. Yeah, why not? Because reflection is slow and less secure, but performance was the main thing. And we got microprofile, which at the beginning I completely ignored because it was a subset of Java E. But now we got something interesting like fault tolerance health. I forgot to write it down. Config is the most interesting one, which I forgot because at the 10 years ago on stage, I hacked for you a configuration API with Jakarta E, which we can actually delete. It's no more needed because we get config property annotation, which I actually use all the time. Less abstraction, less encapsulation, build time optimizations. This is a huge one. So what is now the largest difference between application servers and now? Application servers back then, what they did is they watched a folder, a directory. If something changed, they looked into the war and applied magic. So they read the annotations, deployment descriptors, and generated bytecodes on the fly. This was high dynamic behavior. And this was deployment. Right now, the same happens at build time. It means if Quarkus builds, it does exactly the same, what happens 10 years ago, but it doesn't use reflection anymore and generates bytecode in advance, and there's no reflection. This is why it starts so fast. It starts as fast as Java can start because it just loads the static bytecode. And there are no class loader. Also forgot to mention that. Back then, we had a hierarchy of class loaders with the hope that we can run libraries in different versions at the same time. No one does it anymore, so there is no one single class loader. So surprisingly, after 10 years, runtimes became less sophisticated. Not more powerful, less powerful. Interesting. Okay? So build time optimizations. And we got Java 17, Java 19 right now with Loom preview. Already a lot of projects I know migrating from reactive programming to nothing, basically. So what Loom will do is Loom will kill all use cases for reactive programming where the problem is blocking, thread blocking. There are still remaining cases where you have a workflow-like behavior. So you're building like a facade and you will coordinate microservices and you need the DSL. If you like the DSL, reactive programming is good, but in most projects they wanted to use reactive programming to scale better. These use cases are gone with Project Loom because we can start millions of threads and without any additional overhead. No questions so far. What's wrong with you? You know it, right? So this is nothing new, maybe. So then faster. Microservices, I never got the idea why it is good to split the application in 50 small microservices and hope that it actually works better than one. And I would say monoliths are bad, back, not bad. So back, not bad. They are great, not. And not just me, interestingly. So more and more people are talking about that a monolith is actually good. I never got the idea why a distributed system is easier than a single blob. What we do, I try actually right now to build as large application as possible, but simple. No abstractions, nothing, beautiful Java code, and just one. To give you an example, in my current project, we have 400 is German, 400 Java classes, and in one AWS Lambda. Works perfect. So deploy time, like 1 minute. We can, the response time, this entire microprofile, 30 milliseconds if we not talk, to the backend. If we talk to the backend, it depends on the backend. So no problem at all. The question is, if I would split one Lambda to, let's say, 20 Lambdas, why I will improve the situation, what I expect from it. Okay, so to give you now, and this is actually what happens. What we do right now, we are looking at existing enterprise applications, and we have to migrate to cloud. So now the question is, why we have? So what happened to me since the pandemic, we got additional requirements, which were not able to be fulfilled on premise. And what happened is some companies run out of space in data center. So they had to move to the cloud. So this was the first one. The next one was disaster recovery. So they had one data center, but because the online stuff became more and more important, they needed another one, which is close enough for latency, but they couldn't get one, so they were also forced to go to the client. And the last one is interesting, was security. So it turns out, so in Germany we have lots of standards, secure standards, but the cool story is a cloud is certified in every possible way on paper. So, and this on paper is very, very, very important on paper, because I cannot argue, I can tell you my code is secure, but don't listen to cloud. They say, okay, where are you certified? So I'm nothing certified, then I will lose. So, and the cool story is the cloud architect, they have people who care about the papers. So I put one guy from the paper company, from my company, another guy from the cloud company, and they had a chat, and then everything was sorted out, and we could hack. This would be mission impossible, at least in Germany, that I would explain them, why we are secure or not, because there was no certification. And one is C5 test start. This was the hardest one. C5. This is German test start. If you search for this is the highest certification, and to my BSI is the German CIA or whatever. And but the interesting part is it is implemented by all the clouds. But for me, it would be impossible to implement something in my own Kubernetes cluster which actually does that. So this were actually 3 reasons. We never had the reason because of scalability, whatever no one cared about. Also not about global. So always in Frankfurt in my projects right now. So, okay, questions? Everyone agreed? So now I had a problem. I am, and I was, very happy and successful on premise. We cannot stay on premise anymore. So we cannot use my OpenShift. I use OpenShift a lot. I really like it. So Orantia. So these are my both, Kubernetes environments I still like. But it never, for me, it was crazy to run, Kubernetes out of by myself. It's like, I had a guy, also a German, who compiled Linux kernel to have the best possible executions. Okay, compile, but I don't have time for it. So, and this is this running on Kubernetes is similar. Of course, if you are Snapchat or whatever, go for it. But if you are a small enterprise project, there should be no time to run your own Kubernetes. So this is my personal opinion. My context is never Snapchat or YouTube, right? So I'm working for more boring companies. So so what happened now? What we can do, right? We can pick OpenShift and go to the cloud. Take a look at the license costs. They are nice, right? So it will cost you a little bit. If you run your own Kubernetes on the cloud, you have to think about patching. So you can run, EKS. Then once a month, you get, a call, please upgrade your cluster. And the next interesting part, what really interests me, is if you're running Kubernetes, how you develop your application. So you have a development cluster, do you have an integration cluster and production cluster? For every cluster, you're paying 100 euros a month for control plane, which is not bad if you have 3 clusters. What we do in serverless, every environment, every developer gets an own full stack environment, and it costs nothing. This is the advantage of thinking. So my question is, what do we do? Should we pick our OpenShift and just lift and shift it to the cloud, but no one will be satisfied because everything is more expensive and there is no additional added value. So what we did instead, we look at the source code, pick the source code, and migrate it to the cloud, and then use at least Fargate, something like Fargate, or Azure Container Apps, for instance, or Lambdas or Azure Functions. And it worked better than expected. So this is a short story, what happened in the last 10 years. And this happened the last 2 years for me, but maybe interesting to you. And the running cost of Lambda is between nothing to a little bit, because you are paying, how often the Lambda is executed. And the last thing which I really like about cloud is the transparency in the invoice. I go to management and say, this use case costs you that much, and this use case costs you nothing, and we optimize according to dollars, zloty, or euro, but not to CPU. So what we're actually doing, we are shipping to cloud proof of concept, see how expensive a use case gets. If the use case is too expensive, we optimize the use case, but only then. The problem I had with Kubernetes, you have to pay for Kubernetes all the time, and no one knows what's inside, and management asks why we pay so much. It's like, no, because we are running all the stuff in one Kubernetes. So what the stuff I can show you, and pick your Helm chart or whatever. Okay? So this is actually, so what I'm talking about, if you like to improve your situation, it should be really improved. So what I don't like is just, refactoring. So we refactor the application, lift and shift, and go to the cloud and hope it is better. Why it should be better? It's going to be more expensive. And it's going to be that expensive that some companies are moving out from the cloud repatriation back to on-premises because it's way too expensive. Questions? Everyone agreed? This cannot be. If everyone agrees with that, I mean, I get so much trouble with this statement. So everyone has to say you are stupid and it works completely differently and we apply nothing and Kubernetes is great and whatever. Google Kubernetes engine is the only Kubernetes engine which makes sense because Google is the inventor of Kubernetes and they have the best engine ever. So if I would use Kubernetes, then at Google in the cloud. GCP. Yeah. The problem with Google is no one in Germany has Google except Deutsche Bank. So it will change. So with then more and more banks will expect Google Cloud, but right now, if I mention Google, I'm out. So no one would like to have Google. And what I even heard that Oracle Cloud actually is, I know it's crazy, it's maybe to try out the best one because they have a 3 real free tier. They are really free, and they are actually good. But we know. But if you like to be objective, you should also consider Google Cloud. Just saying. So not Google, Oracle Cloud, OCI. The only problem is if they talk about OCI, I always think they talk about the driver. Because the JDBC OCI is like, why you are so excited about your drivers? We used it 20 years ago. This is open cloud infrastructure. Okay, and the last, yeah.
Can you tell something more about applications that were moved from OpenShift to serverless? Because it cannot be that simple, and I guess there was some cost, since it couldn't be just a lift and shift.
No, it was never lift and shift. I'll show you the challenges. And what I just wanted to mention is this. What I also reject to do, one time I didn't manage because I have to do it next week, Terraform. It's also very similar to Xdockler technology for me. To understand for loop, you need a PhD, and if statement is already extreme knowledge. If you are able to in Terraform from scratch, create a for loop with an if statement, you are already an extreme expert, right? It's a DevOps level 3. So what I do is I use CDK, Cloud Development Kit, and now that comes with Java, of course. It was not as popular because no one knows that it's actually possible. The cool story is, if you combine CDK with Maven, it's crazy what you can do. You can create your own serverless environment, subnets. Let's say you are not, to Lambda is maybe too much. You would like to go to ECS. It's very similar to OpenShift. Then what we did, we create a cloud app or something similar, Java method add microservice with CPU name, and then it created the entire stack from scratch. Because it knew, okay, now we have 32 CPUs, but as I did it, only 4. So we say, okay, if we have 4 CPUs in total, we can split the entire network. You can prepare everything. Why Maven is great? Because you can push the jar to Maven Central, not Maven Central of your company, the Sonar type or whatever. And if new developer comes, it just says new microservice and it's done, one-liner. The same code with Terraform would be like 3,000, at least Terraform. And what is the worst possible thing about Terraform? If you start with Terraform, no one knows where to store the state, which is very important. If you use CDK or an Azure Bicep, the state is stored globally in the cloud. Why? We have no time to explain it, but the state is important because this is declarative. You say, I would like to have, a new subnet, and there is a diff between your environment and the cloud environment, and the diff happens behind the scenes. Okay, back to monolith. EJB simulated is what it said. Dependencies are evil right now. Because of security, this is what I preached for years, is now a reality. So I can go to projects like you don't need Jakarta Commons Lang 3, and you don't need string blank, and it is deleted, which is great because I was ignored for years, but now, okay. Yeah, this is what I basically said. So this was Sun Java Web Server, was distributed. This was Jakarta or Java E. We had web container, EJB container. This was 2012, what I showed you on stage. There was one war with EJB on application server. I think I used Glassfish back then. So this is what I used until 2 years. So we had a microprofile runtime, usually Quarkus, because it's very compatible with this what I did before and extremely fast. Oh, and the problem is, all my clients got memory issues with OpenShift on premise because there's RAM was always the limitation. And with Quarkus, we can halve the amount of memory at least. So even in a podcast, this one Swiss Insurance, they migrated from, I forgot what, either Whitefly or Open Liberty to Quarkus, and they were able to save a half amount of memory without GraalVM. With GraalVM, this is just additional knob, you will save 90% of memory. So on-premise, great. In the cloud, doesn't matter. This is the interesting part. On-premise, very good. So this is why Quarkus, and this is what I do right now. We don't have Docker anymore because Docker is also a problem. If you have a Docker, the question is, what is the super image of the Docker? All the projects go with UB8. You push UB8 to ECR and you say, okay, there is a JPEG finding. Okay, what I can do, this is not my image, right? So all the companies would like to have their own images. If you have own image, you have to have your own JDK. You have to patch your own JDK. And why? What do we do instead? We say, this is a function.zip or on Azure function.jar, I think. And we just tell AWS or Azure, I would like to have Java 11. On Azure, I get OpenJDK from Microsoft. On AWS, I get Corretto. And right now, most of my projects are on AWS, but this is just accident. This is why I tell more about AWS, because they are too similar, both clouds. And if you talk about both at the same time, you get really confused. So for me, I have all the names in my mind right now. Okay, by the way, you get, of course, Kepi, because this was OpenShift. Very good question. So, Java, you can still save money because Java executes on Lambda faster than Node.js or Python. So if you measure this, it runs 10% faster. 10% faster means 10% costs, monthly costs, done. So it is not enough, to migrate from Python to Java, but you should not migrate from Java to Python, okay? So why clouds, I explained to you. So this is shared responsibility model. And with this shared responsibility model, what it means, cloud, Amazon, the same slide is available from Azure. This does the cloud, and you do this, which is boring, because we did it all the time. If I'm in the cloud, I don't like to patch my operating system. I mean, why I need the cloud then, right? This is like crazy. And by the way, if you think about this, at the beginning of the entire enterprise, Java EE, we were serverless. I picked my war, copied it somewhere, and it was installed. So we never cared about the operating system, for instance. So we get now exactly the same. So I would say serverless in the cloud is this what I had on application service with application service on premise, one-to-one. This is why I like it. And everything else is okay, but it's a workaround. If it is not serverless, then the last thing, developers don't care. But what I did, per fun, in management meetings, we said, I said we are running Lambdas in Frankfurt. And we are CO2 neutral. This is a very green technology. And the managers forgot everything. But after they said, to me, we know your solution is sustainable, nachhaltig in German, so very nachhaltig, and I was the king. But this was nothing, right? But this is CO2 neutrality becomes more and more important. And what I saw in Germany, this is what I didn't knew recently, some companies are forced to make open, how much CO2 consumption happens behind the scenes. So this could be actually a quick hack to introduce Lambdas. Because they generate less CO2 as whatever you don't like, right? So this is actually pick whatever you don't like and say, okay, soap generates more CO2, so go to Lambdas, right? So next step is this what I like. If we go to the cloud should to care about everything. I don't have to do nothing, just focus on my business logic. So this is the most extreme point of view you can get. Otherwise, stay on premise. Nothing against that. So if I have my own server, I have also my own server. Lots of stuff is running on my server. And I use just cloud for fun in my private, space. And I don't even suggest my clients to go to the cloud. If you're happy on premise, you can be extremely productive on premise. And we have even, production environments, smaller teams with Docker without Kubernetes. Works great for years. Highly available. Works perfect. So entire production lines are working, on 2 Docker containers and HR proxy. So if they would move to cloud, why? It even only gets worse, right? So I told you, if you have these specific requirements to go to the cloud, then do it right and provide some added value. This is the only thing, right? So, pay as you go. So this is, I don't knew that how much I was, so this was maybe exaggerated yesterday night with this slide. But infrastructure as code, this is, I show this in the source code in a second, but this is the code to deploy one single Lambda with Java. This is actually, except for them, what I plan to show you in a few seconds. And and you have the Lambda function here. In another such a construct, you say load balancer or HTTP API gateway, here's the Lambda. And if the Lambda is in the subnet, you can add VPN to it or not. So this is how the cloud code looks like. We compile it in Maven, we build it, and now it comes what we do actually locally. So this was Universe 2012. Uni new, a great name actually. We have to be more structured because in 10 years I have to show it again what I did now and whether it is okay or not. So what I always do, I have two environments. And by the way, I still use NetBeans. I like it. The problem with Visual Studio Code is it is better with web components in ES6, and I have to edit lots of stuff in parallel. What I did right now, there was a script which opened to Windows, which is harder with NetBeans. So it is but Visual Studio Code use actually all the time, and NetBeans for if I spend more time in one Java project. Okay, what this is one project, Lambda and CDK, in one folder. And the folder is uni-new. And this is CDK on Lambda. And this project is available on GitHub. So you can just clone it and you have it. So this actually cloned my template from GitHub. Why I did it? Because people said this is not possible with Java. And now more and more projects are using actually this. And I even got a patch from AWS because they provided some, they deactivated the tiered compilation to start faster. So, and there's a simple script which runs the CDK from AWS, and this is basically it. So what it means is if we have a microservice, there is a folder with two subfolders, CDK and Lambda. Lambda is business logic, and CDK is infrastructure as code. Now the question is how the code looks like. So if we go here, source, main, Java, greet, and greetings. So long story short, it is almost identical to the code 10 years ago. So I could show you this. You have to believe this is recorded. So I actually decided not to do the migration because it would work. As you can see, this is JAX-RES, is almost identical code, and we still use it. What changed is what I can, if there is a time and you have no asking questions. So this is new. I use, for instance, for dependency injection this config property, and we say default value is this, and this can be overridden in Lambda environment or Kubernetes with environment entries. It happens, so on Lambda it is, I'll show you in a second. In CDK, this can be overridden if you like. So it can be versioned and configured. So the same code. Now the question is, your question is not answered. So what is the problem with Lambdas? The problem or feature is, cold start is not a problem because if your application is used a lot, the first execution takes 2 seconds and then is warm. The problem is the EJBs, if you think about EJBs, right? So EJBs were executed in threads inside the JVM. You can still start threads in the JVM, but if request comes from outside, a new process is started. So the main difference between your OpenShift and Lambda is that if there is heavy load, let's say 1,000 concurrent transactions, you get 1,000 Lambda instances with scale great because you can have 6 CPUs. So you can have 6,000 CPUs. You work on 6,000 CPUs, but you cannot share static. You cannot share singletons. So this doesn't work anymore. What you can do, you can have read-only caches, what you do. So we have application scoped, and if the Lambda starts, you can load stuff from the database, and then it keeps it because Lambda gets reused. This works. But you cannot reuse between, and this is the main problem. The next thing which doesn't work is, if you think about this, you know already, right? What is the next challenge if you think about this? Which microprofile spec has problems? 1, Anyone? Hey, Rad. This is the friend from Java 1, and we met in Poland, so we didn't saw us 10 years or what? 10 years after. Yeah, this is a boring, too technical. Metrics. Metrics, if you think about this. If you have a metrics, Lambda is one process, right? And the metrics are stored in the Lambda. If new Lambda is started, fresh metrics. So the Prometheus has to be really flexible to manage the metrics. So we don't do this inside Lambda, for instance, metrics. What also changed, forgot to mention this on the slide. So this is my first such session. Security. The entire Java EE security doesn't matter anymore. We don't use it anymore. What we only use is JSON Web Token, and the security is always handled by either the load balancer or HTTP API gateway. But my clients still, attempt to implement the security inside the Quarkus, which is crazy, because you think about this, you are inside the JVM, then go outside and back. Why? The security should be, implemented, and the border, and in the cloud is HTTP API gateway or load balancer. On Azure the same, but the HTTP API gateways is called differently. I forgot the name, but they're exactly the same component. And it does, the OpenID connect with Cognito on Azure with AD, just Azure AD, yeah. Okay, so this is just the Lambda now. We have no time, almost 5 minutes. So what I can show you, let's see, I was told that the internet is not working, but I would like to build it completely from scratch and deploy it to my cloud. Maybe it works. With a little bit of luck, this is the complete build of that. What I actually planned to deploy the old application to the cloud, I did it yesterday and it works. I removed the JSF and it just works. So what happens now, I built the function.zip, and now the Lambda is deployed without HTTP API gateway. What it means is the URI is ugly, so I use function URL, but if you download the example, everything is there. Now the question about the costs, right? So we can wait a second. And so if you go to calculator AWS, and let's say we have, I told you that this internet is really challenging. But I told you that the memory doesn't matter. Why not? What we would like to do is to have on Lambda is at least one CPU. If you would like to have one CPU on AWS, you have to buy 1.7 gigs of RAM. All our Quarkus applications consume less than 500 megs. So we could do whatever you like. So we have, we're only consuming a third of the memory. So with this setting, 1.7 gigs of RAM, our Lambda has one CPU. Why this? Because there are thresholds. With one CPU, the function starts faster, and it's actually cheaper to run. That's the cool story. So if you run a Lambda on a quarter of a CPU, it starts slower, way slower, and then you pay more. So I would say measure before you optimize. This is cold start, but not from my stuff. It's from a website. Okay, Ruby. But maybe it is very small what happens behind the scenes. Oh, okay. So if you do the math and you say this function is invoked twice per second, and the invocation takes 100 milliseconds, it will cost you roughly 15 euros a month. The entire microservice with several hundred classes. So this is actually the outcome. You can go to calculator AWS and do the math. What's interesting is, this is pity because I lost my connection actually, but what about local development, right? The cool story is, I'll show you something. Lambda. If I go here, and I can say Maven compile Quarkus dev. And now, the Lambda will start locally. This is my Quarkus application. And everything which is in the cloud runs locally, the same code. The question is, how it's possible? So if I go here, and I say, okay, localhost, this is Quarkus, and this was, I think, hello. Quarkus. So if I change here something, let's say, then hello JDD. So the cool story is why it works, or what's the difference between cloud and not cloud. The difference is this. There is one single extension. If you add the extension, Quarkus with Maven clean package would create function.zip, not executable jar. And this function.zip is taken by CDK and deployed to the cloud. I can have a profile, and if I remove it, it will create Quarkus jar. So you can have actually the same code from 2012 and run it locally as GraalVM, as Lambda, and in Docker. Why to do this? There's one use case. If you have the same code, which runs everywhere in the same way, what we do on AWS, this I'm not sure, I never did it on Azure, but on AWS, you can have a load balancer, same code, Fargate behind, Fargate is ECS, Docker container, and one Lambda with the same code. No, you don't have, you eliminated the cold start because the container runs all the time, and you can handle peaks with Lambda. Same code from 2012. We have no time, it will run, it is identical to now. I use CDI events, they are running, and maybe I'll record a YouTube video to show you that it runs, but I think we are almost over time, right? 5 more minutes. So then ask questions, and maybe it, I really wanted to show you that it deployed that. The technicians told me I should use my cellular phone connections because the wireless LAN doesn't work. This is fault from them. So let's try. What is it? It is no. Okay. Questions? Ask. Yeah.
Thanks. So if you're going to serverless, you might end up with like a lot of lambdas, depending on the project, right?
And not in our case. So one Lambda, as many classes as you can. This cool story, there is no difference in performance. So create a, and what they also saw, no one asked the question, this is a regular endpoint. You can have, hundreds of endpoints. What Quarkus does, it receives the HTTP API event from Lambda and dispatches this to different JAX-RS endpoints.
Okay, so basically this is like a, let's say, bigger Lambda.
Fat Lambda, monolithic Lambda.
All right, so this is how you organize it. Because I was just wondering.
Yeah,
if you
we are migrating microservices one-to-one to Lambdas and measure the performance, and the performance is very good.
All right, thanks.
And what you don't see is this cold start time. It will be roughly 3 seconds, and after that, 30 milliseconds response times.
Okay.
And I have already here entire micro profile inside the Lambda. So it is like from 2012, no kidding, with a dependency injection, and it works. And why it works? Because Quarkus optimizes the entire stuff. Even if you use the dependency injection, what Quarkus does is it hardwires the bytecode. So there is no difference. That's the cool story. So this is why you can pick, your old code and run it in the modern environment. Of course, Lambdas are more expensive, 20% more expensive than EC2. They have to be. But running EC2, you have to patch everything. So it's out of, that we lose all, all the benefits. And what serverless means for me is, if possible, no subnets, no networks, no IP addresses, just, this is the best. So Fargate is gray area because it is serverless, but you still need subnets, but yeah. And what I forgot to mention, with Lambdas, in my current projects, we are allowed to be in the public cloud. But all other projects are private. I don't know how to call it. So they have direct connection between on-premise and the cloud. So this is like direct connect is called by AWS, or express route on Azure. So the service is not available in the internet.
Yeah. So if you're, let's say, designing a Lambda, right? Like, what's your goal to achieve? Like, is it like to?
I'm misusing Lambda to run simple logic cheaply. No
Okay,
goals.
but like you're focusing on
Not single
on some kind of use cases, specific use cases of the
No,
the
it is
code,
like
or-
what he said. We have no HTTP API, and we have to run it somewhere. So we pick a Lambda. So this is like no single purpose functions, no cloud native. It's just misusing Lambdas to write simple code and run it cheaply. And I'm not interested in all the best practice. By the way, I wrote an article about this on AWS blog, and it was accepted. Now it's official. So because they're before me and after me, single purpose Lambdas, and write 100 Lambdas, they know each other. Like we had it in Java already, right? I was in Java user group in Posen, I think, and someone stood up and say, we are launching 100 microservices, but how they find each other? It's like, why do you have 100? How big is your team? 5 developers. Okay, we thought we have to do it, right? No, you don't have to, right? So microservices is a workaround, not a best practice from my perspective. So after that, we can do it next year. What we are doing, we're misusing Lambdas, but let's say there's one killer use case where it changes everything, right? If you would like to upload file to the Lambda, what we would do 2012, we will download multi-part extension and do it with REST Easy or Jersey. With Lambda, with the new cloud native, complete different story. I will upload directly to S3. S3 emits an event, and asynchronous Lambda wakes up and does something with it. And this is the true, asynchronous Lambda architecture. So we have both cases.
Sorry, we don't have any more time for questions.
Last question, maybe, no? He was already. Yeah.
Okay, just a quick one, because we have the Jugmeister ceremony right here in this room in a second. So, be quick.
So when not to use it? When never to go to Lambda? What would be the use case not to do it?
Right now, we need long polling. It's not economical to do it with Lambda. Or if you need shared cache in Java. I mean, this is, if you have something like this, I mean, if you think about this, if Lambda is like CGI, process, right? CGI bin 20 years ago. And sometimes it's not possible to map your business code to this, right? And but what I told you with WebSockets, you would do this differently. There's AppSync service. Lambda would send an event and go through AppSync, but it's harder to implement. So I would say it doesn't matter, because you can start with Lambda, it's the simplest. And if it doesn't work, then go to Fargate, not other way around. You will lose nothing. So because with Fargate or ECS or Azure App Container Service, you have to set up the network, CIDRs and all the stuff. With Lambda, there's just, do it. And if you download this CDK template from me, this on the slides, you need an internet. It's very important. Without internet, it's hard. Internet is the prerequisite number 1, but then you can push your Lambdas to the cloud. It should work out of the box. Exactly, he's absolutely right. And if you have Lambdas, he will hack them anyway, so don't use them. So there's a security expert, right?